Good morning, Algebra 2 trigonometry students. You're listening to Math Sounds with Sindoni. Today's episode is brought to you by the letter C for COVID. Actually, just kidding. Today's episode is brought to you by Miles Morales' Spider-Man that I won in a crane a couple years ago. Yeah, he's going to sit right here. Alright. We're going to look at Chapter 2 for these next couple days that we are home. It's a very short chapter, so I'm just going to do one video on the whole thing, and then you can do some problems that will be due on Monday. Alright, so let's start off with Chapter 2. Okay, we'll look at Section 2.1, which is labeled Graphs of Equations with Two Variables. Graphs of equations with two variables. Alright. Normally we'd do the quicklys, but we're not going to do that today. I will show the book pages at the end of this video, so you'll be able to do the problems and or read through the sections if you would like to. Okay, so what are we talking about with graphs with two variables? You've already seen this. We've been doing one variable so far, which was your straight x graph here, where we filled in and then shaded for the inequalities. Alright, two variables, we're going to add the y-axis. Okay, whoops, arrows. Alright, and then this is called the Cartesian plane, if you've heard that before. Cartesian plane. Alright, here's an example of a function here. 2x minus 3y equals 15. Okay, we need both x and y to satisfy this equation. And the simplest way to do this is to pick some random value for x. Let's say x equals 9. What is y? Question mark. Alright, so we will substitute in the 9 and then solve for y to figure out what our answer is going to be. We get 18. Subtract 18 quickly. Minus 3y equals negative 3. Therefore, y equals 1. So when we get our answer, we write in an ordered pair. Ordered pair. Here's our x value, also called the abscissa. And the y value is called the ordinate. Alright, those are official terms that you most likely don't need to know. Alrighty. Alright, that's it. There's section 2.1. Okay, section 2.1 right here. Oops, a little glare here. Focus. There we kind of go. Okay. Here are the exercises for 2.1, which I will probably assign a couple of those at the end. Alright, oops, Spider-Man's out of view. Here we go. Alright, let's go to section 2.2. Alright, section 2.2, we've got graphs of functions. Talk about domain and range. Okay, domain is our x values, of course, or your input, or your independent variable. Independent. Y values, oops, output, dependent variable. When we are graphing In most cases, it's easier to get y by itself before graphing, especially if you're plugging in points for x or numbers for x. All right, so for our example from the other section, all right, in this case, how do we get y by itself? Well, first I'm going to subtract the 2x term over. So those go away. I'm left with negative 3y equals negative 2x plus 15. I like to write the x term first because that's how our slope-intercept form is going to look. Then I will divide by negative 3, everybody, and I will get 2/3 x minus 5. So this just makes it a little easier if we're going to substitute in x's to get our y's. We can do a little table, quick table here. Let's see. Now looking ahead, because I see I have a kind of a fraction here, I want the 3 to go away, so I'm going to pick multiples of 3. So I'm going to pick 3 and 6, and we already did 9 on the other page, so I'm just going to do this right here. And if I plug in 6, I'm going to get 4 minus negative 1. And if I plug in 3, I'm going to get negative 3. Alright, that's going to go, that's going to cancel. 2 minus 5 is negative 3. And then if I graph this, we're going to get 3, negative 3, and it's probably more like here. 6, negative 1, 9, 1. It's not really, it's close enough. It's a line. It's supposed to be a line. This guy should be right here. Okay. We have our, sometimes we're going to have parabolas. Okay. We got y equals 0.2 x squared. And this is our parabola. It's good to have more than 3 points for a parabola because, you know, it's got that kind of curved shape here. So we'll leave that for later on in the book when we get to quadratics. Be careful with stuff like this. When you have our non-polynomials, which we talked about, we can't have 0 in the denominator. So in this case, we can plug in anything except for 2. All right. Okay. Oh, one other thing I want to do. Let's get an example. Example 1. We're going to plot, well, we might plot it. Y equals 10 over x. If, now there might be a if the domain, we all know this guy likes to restrict domains. So if the domain is the integers between 1 and 3 inclusive. What does inclusive mean? Oh wait, you're not here. Inclusive means you're including the boundaries. So 1 and 3 are included. So in this case, the domain is going to be 1, 2, and 3. Alright, that's only domain values I have. So those are the only values I can use. So the only ones I can plug in to here. So I should only really get 3 values back. I can't get any more. So if we plug in 1, 10 divided by 1 is 10. If I plug in 2, 10 divided by 2 is 5. And if I plug in 3, 10 divided by 3 is 10 divided by 3. We'll just keep it as a fraction. Always looks prettier that way instead of decimals. So that would be the range for that. We won't plot it. I just wanted the range values. Okay. Alright, good. That was section 2.2. Nope. Where are we here? Graphs of functions. Graphs. Ooh, look, there was 0.2 x squared plotted. That looks messy. We weren't going to do that. Okay, over here. This is just for you in case you want to read the book, since I don't think you took it home. Yeah, we did that. We only did a few of them. I kind of cut it in half. Okay, and here are your exercises for when I assign a few of these at the end. Okay. Let's move on to section 2-3. Oops, new page. 2-3, functions in the real world. Ooh. Alright, we're going to look at page 58 here. And we're going to look at example 1. The time it takes you to get home from a football game and the speed you drive are related to each other. Sketch a reasonable graph showing this relationship. Alright, so you're driving home from the football game, and we're going to just kind of sketch out a graph here. If you're driving home, okay, we have two variables. We have your speed, and you have the time it takes you to get home. Okay. Now you have to decide which one's x, which one's y. In this case, you have to think about which one depends on the other. So I would say in this case that how fast you go will determine the time it takes you to get home. Okay. So in this case, usually time is x, but in this case we're going to say speed is x. Okay, because the time actually depends on the speed of you traveling home. All right. Most of you don't drive, so you don't really know what that means. All right, so let's take a look at the relationship here. The faster that you go, the less time I think it would take for you to get home. So if you're blazing fast here, you're probably going to take not a lot of time to get home. However, if you're kind of taking a nice Sunday stroll, your time is probably going to be a lot more. Okay, and if you're in the middle, it's kind of in the middle. So in this case, this is probably a little curve here. I guess you could do a straight line, but it's not perfect. Got a lot of traffic stops, so this is varying, but it's just kind of to get you an idea how two things are related to each other. One thing that I want to go over is, if you notice, we're not going to talk about that. That's okay. Alright, cool. Let's do one more. That's a good one. Let's look at number 2. Number 2. The number of used aluminum cans you collect and the number of dollars refunded to you are related. Sure they are. More cans. Let's look at this one. Okay, so I would say the cans you collect is the x, and then the money you get would be the y. Okay, the amount of cans determines the amount of money you get. Okay, the amount of money is dependent on how many cans that you collect. All right, so in this case, you collect some cans, you get some money. You collect medium cans, you get medium money. And if you collect a lot of cans, you get a lot of money. All right, now in this case, you and I both know that there's only one fixed price for cans, although some places do 6 cents, but we're just assume it's 5 cents. Because that rate is the same and constant, we know this is a line. Straight line. Okay, it's linear. Okay. Oh yeah, here are the problems that we'll see. There we go. Obviously, I'm not going to sign all of these. Just a few. Alright. Last section. No, I don't think I'll assign any of these back here. Okay. 2-4. Graphs of relations and or functions. I think I wrote that backwards. That's okay. Okay, a relation is a set of ordered pairs. A function is a relation for which there is exactly one y for each x value. Hopefully what you've seen before is using the vertical line test for graphs. If you hit 2 points at once, it fails. If you hit 2 points at once, not a function. For example, if you have something like this, oh boy. Woo! Okay, if you do the vertical line test, you're fine here, and then all of a sudden you get to this weird S part, and right here, and all in this area. That's bad. Bad. Not a function. Okay, gotta focus up here. What's going on? Focus. There we go. That's bad. Okay, the way to see it for other things, if you have a table, let's say you have a table, you're looking for repeated x values. So if you have something like this, alright, if you have something like this, come on. What happened here? Oh well. We have 2x, two twos right here. That's bad. Man, come on. Oh, there we go. I'll just go a little closer. There we go. All right, so in this case, we have 2x values here. Okay, we can't have that. There's also something called a mapping, which are these bubbles to put your values in. Oh, that's pathetic. Let's try that again. That's better-ish. Kind of. Not really. Okay, and what you do is you draw arrows to what numbers that they coincide with. So, like, if I draw arrows here, this means that there's a point 1, 2 in the relation. Okay? And I'm going to keep drawing some more arrows. Where did I do that one? Oh, that's fine. Okay. Okay. So if you notice, I have two values coming out of 4 here. Alright, so that's bad. Not a function. Okay, not a function. It's okay to have double y's. Double y's. Okay for function. Alright. That's that. Here's section 2.4. Wow, 20-minute video. Crazy. Can you see that? There we go. Alright, there's your vertical line test. And then here are the exercises. Draw a parallelogram. That's funny. Okay, here are those. Here's some graphs to do the vertical line test on. Okay. All right, folks. Thanks for listening. Whoops, you're not pre-calc. Spider-Man says bye. See you Monday.